Um, just as a reminder, this quiz will be on Friday of this week. Um, what I will be asking you to do is to solve logarithmic equations as well as exponential, and then be able to use these properties right here. If you know those properties and you know the inverses and you know how to work with these, this quiz shouldn't be very hard. This is a rough draft of this quiz. It will probably be about the same length, but these questions are asking relatively the same thing. So I'm just going to start doing them. As you have questions, just, again, type them in or email me. So number one, you can do this a lot of different ways. The way I would expect you to do it is to use the one-to-one property of exponentials, which if we rewrite this right here, we can get if a to the power of x equals a to the power of y, then x is equal to y. So that's what we're going to be doing with number one. So on the left-hand side, we have a base of 9. I'm going to make this just a little bit bigger. So on the left, we have a base of 9, and on the right, we have 81. We need a common base between 9 and 81. So the most common base would just be 9. You could use 3, but you have to do a little bit of extra work. So the left-hand side stays as 9 to the negative 2n. And then 81 is just 9 squared. So now that we have the same base on both sides, they cancel. So negative 2n is equal to 2. So n is equal to negative 1. On number 2, again, we're going to be using the one-to-one property just with exponentials. On the left-hand side, we have the base of 4. On the right-hand side, we have a base of 1. So the way I would do this, I would leave the left-hand side alone. And going from the properties of exponents, we know that 1 is also 4 to the 0 power, because anything to the 0 power is 1. Once we have that, we have both sides with the same base. So 2x will equal 0, and x will equal 0. Number 3, on the left we have a power of 16, on the right we have a power of 32. So we need a common base between those two. My initial thought is to use 4 because 4 squared is 16, but 4 cubed isn't 32, so we need something a little bit smaller. So let's try 2. So 16 can be written as 2 to the 4th. Yeah. So 16 is 2 to the 4th, and then this r minus 1 stays on the outside. 32 can be written as 2 to the 5th, with the 2r plus 1 on the outside still. And then again, we can use our properties of exponents. This 4 will distribute to the r minus 1, and this 5 will distribute to the 2r plus 1. So when we do that, we get 2 to the power of 4r minus 4 is equal to 2 to the power of 10r plus 5. Now that they have the same base on both sides, we can cancel them. So 4r minus 4 will equal 10r plus 5, and then we can just solve that using algebra. If I subtract 10r from both sides, we get negative 6r, and then add 4. So negative 6r is equal to 9. R is equal to negative 9 over 6. On number 4, they both had the same base already. So we could just take their exponents and set them equal to each other. So 2 minus 3b is equal to 2. Negative 3b is equal to 0. So b is equal to 0. On number 5, the left-hand side, we have a base of 3. On the right-hand side, we have a base of 4. There is no common base between them. 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81. So there's nothing that's going to get us anything close to 44. So then we have to use some of our properties of logarithms, as seen up here. Also, they should be in your notes. All right, so in order to do this, you need to think to yourself, what is the inverse of exponential, which is what this equation is. The inverse of exponential is logarithmic. After we establish that, you ask yourself what the base of the left-hand side is. That base is 3, so we want to take the log base 3 of both sides. And again, the reason we take log base 3, this 3 becomes our base, and we're trying to cancel them out. So we have to take the log base 3 of 3 to some power. When we do that, the log base 3 and the other base of 3 cancel, so you're just left with 2k. And then the log base 3 of 44 stays the same. And then if you divide both sides by 2, you get your answer. Number 5 is very similar. Except this time we have a base of 5 on the left-hand side. And in order to undo that base of 5 so we can get the exponent by itself, we want to take the log base 5 of both sides. When we do that, the log base 5 and this base of 5 cancel. So we're left with negative 5x. And then we're left with log base 5 of 52 on the right-hand side. Then we divide by negative 5, so to get x is equal to log base 5 of 52 divided by negative 5. On number 7, we're basically just adding one step to number 5 and 6. So think about 18 to the negative k as its own unknown. So in order to get that blue box by itself, we have to divide by a negative 4 on both sides. When we do that, we get 18 to the negative k is equal to negative 69 over negative 4. And then we have to get this negative k by itself. In order to do that, we have to take the inverse of a base of 18. So we take log base 18 of both sides. When we do that, the log base 18 and this base of 18 cancel. So we're left with negative k. And then we have to get rid of the negative, so we divide or multiply by negative 1. So k will be negative log base 18 of 69 divided by 4. On number 8 and 9, we are asked to condense each expression. So we have a single logarithm. So we're going to be using these properties right here. So when we have, well, first we have to simplify this right-hand side. So everything stays the same for the first part. Except for the right-hand expression. So if we were to condense 6 log base 7 of z, that can be rewritten as log base 7 of z to the 6th, because this 6 becomes the exponent. Then we have a sum of logarithms with the same base, which means we are using the product property. And the product property says that if we have a sum of things with the same base, we can take a single log of the product of each of these things. So we have log base 7 of x times y times z to the 6th. Similarly, on number 9, the first thing we have to do is to use the power property. So we can rewrite the 24 times log base 3 of 11 as log base 3 of 11 to the 24th. And then we can rewrite 6 log 3 of 6 as log base 3 of 6 to the power of 6. Then we have a difference of 2 logarithms with the same base. So we're going to use the quotient property. What the quotient property says is if we have a difference of 2 logs with the same base, we can take a single log of the quotient of 2 things. And I would expect you to get this far. You don't have to carry out 11 to the 24th or 6 to the 6th. Number 10 and 11, we're working just the opposite way that we just did. So we need to expand each logarithm into several different logs. All right, so in number 10, we have log base 8 of x times y times z cubed. So this is a product of several things. And what the product property says is that when we have a product inside of a log, we can rewrite it as the sum of different logs. Now this is almost done. Log base 8 of x, log base 8 of y, those stay the same. And then log base 8 of z cubed has a power inside. And what we can do with that power is put it out front. So log base 8 of z cubed becomes 3 times log base 8 of z. On number 11, there is a power 2 that goes to everything inside. So we should do first is take this 2 and put it out front. Like so. So we have 2 log base 2 of ab to the 5th. Now we have a product of two things. We have a and b to the 5th. So we can rewrite this as 2 times log base 2 of a plus log base 2 of b to the 5th. And then we have a power inside this 5. So we can rewrite this again as 2 log base 2 of a plus 2 times 5 log base 2 of b. So it just becomes 2 log base 2 of a plus 10 log base 2 of b. On numbers 12 and 13, we have a log base of something on both sides. And what the one-to-one property says is that if we have log base, a of x is equal to log base a of y, then x is equal to y. So the stuff inside parentheses can be set equal to one another, and you can just ignore the logs. So in number 12, we have log base 4 on the left and log base 4 on the right. Because of that, they kind of cancel. So we have 7 minus 2m is equal to 5 minus 5m. I'm going to add 5m to both sides and then subtract 7. So we get 3m is equal to negative 2. So m is equal to negative 2/3. Same thing for number 13. The 2 log base 18s kind of cancel. So we get 3x minus 3 is equal to 4x minus 7. If we subtract 3x from both sides and add 7, we get x is equal to 4, and that's our answer. The rest of these we have to use a combination of condensing and the one-to-one property and just what logs are. All right, so number 14, log base 2 of 5 minus log base 2 of 5x is equal to 1. The first thing we need to do is to condense the left-hand side. So when we have a difference, so we can use the quotient property. So this condenses into log base 2 of 5 divided by 5x. And we didn't do anything to either side, so it's still equal to 1. So this is log base 2 of 1 divided by x is equal to 1. Because those fives cancel. Now, in order to undo the log, we have to take the inverse function. So the inverse function of logarithmic is exponential. So what we're going to do is we're going to take this base, and that's going to be the base of everything on this line. So it will look like 2 to the power of log base 2 of 1 over x is equal to 2 to the power of 1. When we do that, this 2 and log base 2 cancel, so 1 over x, and then 2 to the first is just 2. If we multiply by x on both sides, we get 1 is equal to 2x. Divide by 2, x is equal to 1/2. Same thing for number 15. The first thing we're going to do is condense the left-hand side. So when you do that, we get log base 3 of 6 divided by negative 5x is equal to 4. Again, in order to undo the log, we make all of this in red an exponent of 3. So it'll look like 3 to the power of log base 3 of 6 divided by negative 5x is equal to 3 to the power of 4. This 3 and log base 3 cancel, so we're left with 6 divided by negative 5x is equal to 81. If you multiply by x on both sides, you get 6 divided by negative 5 is equal to 81x. And then we have to divide both sides by positive 81. So 6 divided by whatever negative 5 times 81 is equal to x. Obviously, I would want you to simplify that. I just don't have a calculator in hand. And then finally, number 16, again, it's going to look the exact same. First, we condense it. And that's our answer. So this is a good little review. There are some things that IXL did that I really liked that aren't on here. that I will most likely put on the actual quiz. So what I would do is to look over the IXL problems, and those would be very similar. I'll try and get a couple generated here in a second. But this quiz and the IXLs are probably the best thing to study for this quiz. So give me a couple minutes and I'll get some questions. So I'm just going to do this for probably the next 15 or so minutes. There's only one other person watching, so if anyone has any questions later, they can always email me. But I'll just do this until I'm told otherwise. All right. So on IXL, this is F11, which is one of the last ones you'd have to do. We have log of y. Is equal to 2. Because there's no base specified, it is assumed to be 10. And we want to solve for y. So the way you can do this is to rewrite this in exponential form. So 10 squared would equal y. So y would be equal to 100. And this next one, log base 4 of x is equal to 3. Again, if we rewrite this in exponential form, that can be written as 4 to the third power is equal to x. So that is 64 is equal to x. Again, log w is equal to 2, rewrite that in exponential form. So we get 10 squared is equal to w, so w is equal to 100. Log base 14 of u is equal to 1. If we rewrite that in exponential form, 14 to the first power is equal to u. So 14 is equal to u. Same thing for log base 13 of v is equal to 2. Rewrite that in exponential form, so 13 squared is equal to v. So v is equal to 169. So for this one, 2 times log base 36 of u is equal to 1. I would divide 2 by both sides first. So this can be rewritten as 36 to the 1/2 is equal to v, which is the square root of 36. So 6 is equal to v, or u, whatever. So something like this is probably would probably show up on the quiz. Um, we can rewrite the natural log of e to the 70th power as just 70, because the natural log of e is just 1, and then this 70 come out front. So we have 70 over 10, it's just equal to 7. Not to mention all of the ones that I did up here. And then stuff like this, you would have to have a calculator for. Um, so I won't give you anything like this, but you just plug that into a calculator and then get an answer. I'm going to call it here because I think it's just you watching better. So if you have any questions, just let me know. I'll leave this open for the next couple of minutes. All right, I'll call it then.